Now today we are going on to a new chapter, Circles 2, chapter 19, and it's page 185 in your book. Now I'm going to start off by doing two examples from page 186, and this is just to prove that an angle drawn inside of a semicircle will always be a right angle or 90 degrees. Now I'm aware that not all of you might have A3 paper, so what I have is an A4 page, a blank A4 page stuck down in front of me here today. I am going to start off by dividing the page in half, so I'll come over 145 along the bottom. I'll put a vertical line up the middle of the page, and I'm going to do one example on each side of the page. Now, example 1. Construct the right angle triangle ABC shown in the figure across. Now, as with a triangle that we've done before, you always need three pieces of information to draw that triangle. So our three pieces of information, we're told the line AB, the base of the triangle, is 100 millimeters long. The altitude of the triangle, or the height of it, is 45 millimeters, and we're told this angle up here is 90 degrees. So what I'm going to start off with is by drawing the base of the triangle AB, which is 100 millimeters long. I'm going to do this on the left hand side of the page. So you can measure up 50 or 60 millimeters, and I'll put in a light horizontal line. I'm going to measure in about 20 there from the side of the page. And I'm going to draw the line AB, which is 100 millimeters long. My second piece of information that I was given is the triangle has an altitude of 45 millimeters. So I'm just going to draw a light vertical line over the side here, measure up 45 millimeters, and I'm going to just lightly bring that across. And I know that the apex of my triangle is going to be somewhere on that horizontal line. My third piece of information I'm given is that the angle here at the top of my triangle is 90 degrees. So I'm not told what either of the base angles are. What I need to do is use this piece of information that I have at the top of the page, that the angle in a semicircle is always 90 degrees. I need to go and draw a semicircle which this triangle is going to fit into. Now, I already have the bottom here, the line AB, so I'm going to draw my semicircle on top of the line AB. In other words, the diameter of my semicircle is AB. Therefore, the radius would be half the length of AB, which would be 50 millimeters. Now, what I'm going to do here, because we mightn't always be told the length, I'm just going to go and bisect the line AB. And I'm going to draw a light vertical line there then, where my bisector is, and I have the very centre of the line AB. Then, compass right on the centre of the line, set my radius to the end of it, and just lightly I'll draw my semicircle. Now you can see that my horizontal line, which is up 45 millimeters, hits the semicircle or intersects it in 2 points. Point C is slightly over to the left here, where my horizontal line hits the semicircle. I'll call that C, and I'll join it to both A and B. Now, to double check that that angle up at the top there is a right angle or 90 degrees, I'm going to get my protractor, line it up there, and I can see that the line AC and the line AB give me 90 degrees. And I'm just going to put a little note in there showing that that's 90 degrees. Over on the right hand side of the page now, we are going to do example 2. Now, example 2 asks me to construct the rectangle ABCD shown in the figure over. Now, I am only given 2 pieces of information about this rectangle. So I'm told there the line AC is 120 millimeters. That's the diagonal line across the rectangle. And I'm told the side of it, BC, is 105. I am not told the length of the line AB or DC. However, we know that all 4 corners of a rectangle are 90 degrees. So for a minute, all I'm going to start off with now is just a light line, AC, which is 120 millimeters long. So I'm going to measure up there on my A4 page. You can come up halfway, so you can come up about 100 millimeters. We'll draw a light horizontal line. I'm going to measure in 10 from my vertical center line, and then over a further 120 then from that point. So I now have 120 millimeters between those 2 points, and I'm going to label them A and C. Next step. So I have this line AC drawn. If I forget about the bottom half of that rectangle for a moment, and just break it into a triangle, ADC. I know that this angle up here at the top is 90 degrees, and I know that the line AD has to be 105. So what I'm going to do, we're back to our little diagram that we have up at the top there now. So if you imagine this triangle inside the semicircle is ADC, like I have below here. I need to go and draw this semicircle, and then I'm going to see can I locate point D, which will be on the semicircle. So as we did on the other side of the page, I'm going to bisect the line AC. Like so. And I'm going to draw my semicircle just like that. Now, my next piece of information, I am told that the line AD, okay, my line AD here is 105 millimeters. I know that D is somewhere up here on my semicircle, so I am going to set my compass to 105 millimeters. I'm going to put it on point A, and I'm going to swing an arc, and where that arc intersects my semicircle, that there is point D. And then to draw one half of the rectangle, I will join D to point C, and to point A. There's one half of my rectangle. You can double check then again with your protractor. It's that angle, 90 degrees. And as you can see, it is. Last step then, I know that the opposite sides of a rectangle are parallel to each other. So, parallel lines, I'm going to use my sliding set squares to finish off the bottom half of my rectangle. And there is corner B. And there's the second example completed.